Hello everyone. Today we are going to discuss about the internal second paper of data science. We have already covered question 1, which was what are text mining techniques, and a complaint was given. We have to apply the IPC and BNS section to it and make a program for it. Now we are going to discuss with question 2, which is write algorithm solutions or Python or code snippets for the following tasks. And these were the given tasks: data preprocessing, classification, clustering, decision tree, association, rule mining. So I am going to discuss this in Python. So first we are going to discuss about data preprocessing. Here you can see the code snippet I have put. Uh, we are first importing libraries like pandas, sklearn. So we are importing pandas spd, import simple imputer and standard scalar. These are the inbuilt functions in the sklearn library which we are going to use. Now first load the data. So data, then create a data frame. In data frame we are creating a dictionary where key is age and salary and values are list. So this is a nested dictionary where values are in the form of list: 25, done, 30, 35, and here 50,000, 60,000, 9, and 80,000. Now, for handling missing values, imputer, we are creating a variable imputer where we are going to perform a function simple impute strategy is equal to mean. So जितनी भी मिसिंग वैल्यू रहेगी वहां पे मीन की वैल्यू डल जाएगी और डाटा imputed is equal to pd dot data frame impute dot fit transform data columns is equal to data dot column. Now standardizing the data, scalar is equal to standard scale. This is an inbuilt function which is used to standardize the data. Then we are going to store it in data scale variable and transform it. Now just simply print the data scale variable. This was the code for data preprocessing in Python. Now, second part is classification. So here's the code snippet. In this also we are importing sklearn library, and in its functions are train test split, logistic regression, accuracy score. And here for sample data, we have taken two x and y, where x have a nested list of you can see 1, 2, 2, 3, 3, 4, and 4, 5, and y is 0, 0, 1, 1. Now splitting the data into train set and test set, where test set of size will be 25% and train set will contain 75% of the data. Then train the model. This is the syntax for training the model with the function using logistic regression, and then giving parameter to model dot fit, which is x train and y train. Now predicting and evaluating the data. So y predict is equal to model dot predict x test, and then print the accuracy score. So this syntax will print the accuracy of the classification. Now third is clustering. This in clustering we are using k-means. So in this we are importing sklearn library and importing the function of k-means, and we are also importing numpy as np for numerical functions. So in this sample data is x is equal to mp dot array. In this we are creating an array. This you can see that. Then applying k-means. So first in k-mean we have to let the two means then k means is equal to k means. Here you can see that two parameter and clusters and random state. K means dot fit and give the variable x. Then print the cluster centers, which is stored in k means dot cluster centers, and then print the labels. Now the fourth one is decision tree. So in this code, we are also importing skline and the function decision tree classifier for classification and export text for exporting the text. Sample data is given here in the form of x and y. Then training the decision tree. So classification is equal to decision tree classifier and fit में डाल देंगे x and y. Then tree printing the decision tree is export text, and we have stored the decision tree classifier in CLF. So give CLF and print. Then feature names. Then print this variable. Now the last one is association rule mining. So in this we are importing two libraries which are pandas spd and importing some functions which are a priori and association rules. So first create a sample data which is in and using a data frame. So here milk, bread, butter, the amount of frequently times they have been brought by our customers. This technique is mostly used in market basket analysis to calculate what product is being bought with other products more frequently. So they can market the products. Now see here frequent item sets. A priori is a function to calculate support and confidence of the elements. Here data minimum support is zero point 0.5 and use column names is equal to true. Then print frequent item sets, and now creating an association rule variable where we'll be performing association mining. So rules is equal to association underscore rules. Frequent item sets and metric is equal to confidence metric, and minimum threshold is equal to zero point 0.7, which is 70% of confidence and 50% of support. Then print the association rules, and this is the syntax for printing association rules. Now question number third, which was given algorithm for linear classification model for fitting a best fit linear curve in scatter plot. We have done this question also using Python. So this is the algorithm best fit line for linear classification. Give a input a data set with features x, independent variables and target labels y, independent variables 0 or 1. Then step 1 is initializing the parameters, initialize the weights, coefficients for each feature and bias b to small random values 0. Step 2 is define the hypothesis. Use logistic function to compute probabilities. Now, let's talk about this code. So, first we are importing libraries numpy, snp, matplotlib.py, plot, splt, and skline. NumPy is used for numerical computation such as generating random data and reshaping arrays. Matplotlib is used for plotting the scatter plot and best fit curve. In logistic regression from skline is the machine learning algorithm used to fit the linear classification model. Now see generating example data. np.random seed sets the random seed for reproducibility. X is equal to np.random.rand 101 into 10. So this will generate 100 random numbers between 0 and 1. Multiplying it by 10 scales the value to the range of 0 to 5. The target y is binary. Any x value greater than 5 is assigned, and values less than or equal to 5 are assigned to 0, which means class 0. This simulates a simple binary classification data set. And here you can see in the third line y is equal to x is greater than 5 dot s type. Why is s type used? It converts the boolean result of x greater than 5 into integers, and Ravel reshapes the array to a flat 1D array. Now plotting the data. Plotting the data, we use plot.scatter. The scatter plot shows the original data where each point represents a sample. X value are on x-axis and y value are on y-axis. The label is equal to data is used to create a legend. Now fifth is generating the best fit curve. So np dot line space 0, 10, 100. It will generate 100 evenly spaced values between 0 and 10 to represent the x-axis for the smooth curve. Reshape minus 1 to 1, it will convert the array into the correct shape for prediction. Then you can see model dot predict underscore proba x line, which will compute the probability of each point belonging to class 1. Now plotting the best fit curve. This overlays the best fit curve on top of the scatter plot. The curve represents the logistic regression model prediction. A value closer to 1 means higher confidence in class 1 and a value closer to 0 means higher confidence in class 0. As you can see, plt dot plot x line, y line, color red, label, best fit curve. Now seventh is adding adds label and the legend. So adding label and finalizing the plots. As you can see, plt dot x label feature which will label the x-axis, plt dot y label which will label the y-axis, and plt dot legend add a legend to describe the. Then show will display the plot. Now output, now talking about output, so you will be thinking about what will be the result. The scatter plot shows the original data points with binary labels 0 or 1. The red curve represents the logistic regression model's best fit line. It's a sigmoid curve which maps the linear predictions to probabilities between 0 and 1. The curve separates the two classes in a way that minimizes the classification error. This was all about the second internal. So, thank you very much.